Good evening, ladies and gentlemen. When looking at the life we live in today, the usage of electricity increases daily as more and more people are reliant on electricity. The electrical power is generated and distributed to end users using transmission lines. Unfortunately, distributing high voltage power is unsafe and therefore requires protection. Electrical faults can occur on transmission lines. These faults can be caused by nature or the failure of infrastructure. It can lead to the death of humans, birds and animals, along with equipment failure and electrical power supply interruption. The solution to this problem will be to develop a power system fault detection algorithm that can detect electrical faults and notify the safety personnel in a short amount of time. Resources needed for the solution are quality power system data, laptop with high processing speed, and the combination of the MATLAB and Simulink software. The design is divided into the preliminary and detailed design. The network will be operated by a system user that will train the algorithm with data of a power system. The trained network will then be used on a new set of parameters to test the fault detection and classification ability of the network. Thereafter, the network's performance and some extra information will be fed back to the user. During the preliminary design, a requirements and functional behavior analysis was done to add functionality to each resource, and thereafter a quick resource allocation was done to determine whether all the functions are going to be performed by at least one resource. The curve-fitting neural network was chosen for implementation after a trade-off study was done between the different neural network applications. The curve-fitting neural network is based on the Levenberg-Marquardt algorithm that makes use of the backpropagation training technique. The neural network consists of sigmoid hidden neurons and linear output neurons. The power system network was simulated in Simulink and used to obtain the voltage and current data needed for training. The fault was then detected and classified by using a logic circuit. The application can be finished by adding the neural network and logic circuit to the final model. By simulating a double line to ground fault, we obtain the following result. As you can see, the ABG fault is triggered and the fault is detected. The final model achieved an accuracy of 100% when it was tested during different fault scenarios. While designing a fault detection network, it is important to understand how the topology works to be able to properly apply it. It's easy to get it working, but it's important to understand why it works. Artificial intelligence is a complex concept, but with the help of today's software packages, it makes it a lot easier to understand and implement. It's a powerful tool that can enhance the future of AI technology. Thank you for your time, and thank you for listening.